Hello, friends. Welcome to day 3 of tutorial Swift for Beginners. In today's tutorial, we will be learning about constants, variables, and data types. So before we do that, let's say why do we need to write code? Why do we write code? What is the necessity of writing a code? So first is for computation. So as you know that a computer can do calculations much faster than any human can, and that is why any kind of computation will take less time and effort if done by the computer. So we write code to do any sort of computation quickly. So that is the first. Second is simulation. So if we need to do any sort of simulation, if we need to simulate say some system and observe their interactions and observe the behavior of the entities in that interaction, and we can do that by writing a code for it. And as I have already told, computer can do these things very quickly, so it saves us a lot of time. So that is why, that is the second reason we may write a code. So to simulate some real world event or some real world interactions or any abstract concept. And third is record keeping. So as we already know, computer systems are highly efficient in storing and retrieving data, and that too with very high accuracy. So it is, if we want to store and retrieve a very high number of data, then we may write a code for it. So third reason is for record keeping. So these are the three scenarios that I can think of that where writing a code or writing a program is actually beneficial. So that is why we write code. Let's see what will be the real world use case of writing a program. So if you have learned coding, you have learned programming. Now to make use of that programming, you would solve some real world problem, a real world problem, and you will give a real world solution, and that solution will be called a software. So software is nothing but a collection of modules, a collection of programs that could solve a specific particular problem in a meaningful way. So this is the basic overview of software. So you have code, and these are your separate individual entities. So we call them structure or classes in Swift. So we have these multiple classes or structures, these entities, say 1, 2, 3, and so on and so forth, and these will come together and interact with each other, and their interaction will give us some sort of output or some sort of behavior that could help and benefit us. So at the lowest level, we have structures or classes. So this will represent an entity, the lowest level entity, and these entities have properties and behavior. So the properties, as you would see, so if for say a real world example, an entity can be a person. So say a person is an entity, and that person has some properties. So the properties would be his height, his hair color, his eyes, the color of his eyes. So these would be the properties that can define that entity. And again, that entity can also have a behavior. So for example, a person can also have different kind of behavior. The behavior will differ from a person to person. So an entity is a collection of properties and behaviors, and these properties are represented by constant in variables in Swift. So this is where we are going to start. So we are going to learn constants and variables. So this is where we are going to start our software journey. Now, what are constants? Constants are something that does not change. So something that does not change is a constant. So it's fairly obvious. So you would define a constant like this. So let is the keyword, and by writing this keyword in front of your constant name, you can define a constant. So say let date of birth equal to 10th October 1990. So this is a constant. By writing this much of code, you have said to compiler that this date of birth is this, and it is not going to change. So this is a constant. Now what are variables? So variables are nothing but properties that are subject to change. So properties that can change are variables. So how would you define a variable in Swift? You will say where is the keyword, and the name of the variable, and the value of the variable. So in this case, the age is 34. By writing this much code, you have told the compiler that the age is a variable and it is subject to change, and the value of that variable is 34. So now we have learned about constants and variables. So why these properties are divided into constants and variables? So Swift wants you to think about your properties, about the behavior of the properties that you are going to define. So if you know the behavior of your properties, if you know if the property is going to change in the future or not, so you are already eliminating one point of source that could in future results in bugs. So if you know that your property will be a constant and it will never change, so by mistake if you are trying to if you try to change that constant, the compiler will give you an error, and that way you will be avoiding any kind of bug that you might encounter. So by defining the behavior of your property, by defining the changeability of your property from the very beginning, helps you reduce any complication that might occur later in the program. So again, we have different kind of data types, and these are integers, floating point numbers, booleans, character in strings, tuples, and optionals. So we will be learning about all these, but in this tutorial we will not be learning about, but in this video we will not be learning about characters and strings and optionals. So these data types require their own separate video, as they require explanation in detail. So we will only be learning about integers, floating point numbers, booleans, and tuples in this video. So let's see integers. So what are integers? Integers are set of whole numbers. So 0, 1, 2, 3, minus 1, minus 2, minus 3, and so on. So these are integers. So we have two kinds of integers. One is signed integers and other is unsigned integers. So signed integers are minus 1, minus 2, 3, 0, 1, 2. Both positive and negatives are signed integers. And unsigned integers are those integers which only have a positive sign. So 0, 1, 2, 3 are unsigned integers. Now, as we know that a computer have a finite amount of memory, and these type of integers are infinite. So in mathematics, these numbers are infinite. They can extend in infinity in both direction, be positive or negative. But we only have a finite amount of memory in our computer, in our computer systems. So we can only represent a few range of these integers. So what is the range that we can represent? Again, the range will depend upon the compiler, upon the architecture of the system you are working with. So we have, so this is the different range that we have for different type of integers. So again, as I told you, we have signed integers, we have unsigned integers, and depending upon the architecture, depending upon the type that you want to work with, depending upon the size of the integer, depending upon the range, you can pick any of the type of this integer. So this is the range for 8-bit integers. This is the range we can represent from -128 to 127. For 16, we can represent from this negative integers to this positive number, and so on and so forth. So you can take a screenshot. You do not need to memorize all these numbers. And just for curiosity, so you might be seeing that I have written as -2 to the power 7 to 2 to the power 7 minus 1. So if you are curious, you can do a quick Google search as to why we have such specific ranges. So why 8-bit integer is only from -128 to 127, or why the unsigned 8-bit integer is from 0 to 255, and so on and so forth. Next we have floating points. So what are floating points? These are the numbers which contain a fractional component. So earlier we discussed integers. So integers were the whole number 0, 1, 2, 3, 4. But floating point numbers are the numbers which have a fractional part, say 1.04 or pi 3.14. So these kind of number will be represented by floating point numbers. Again, we have two type of floating points. One is float and other is double. So we have two different type of floating points because these two types of floating points have different kind of precision. So precision means the accuracy with which we can represent a fraction. So when we say what is the accuracy, we say we can represent a fraction up to a certain number of decimal points. So higher the accuracy, higher the precision, higher the number will have a higher number of decimal places we will have in the fractional component. So float are 32-bit in size and can represent up to 6 decimal places of accuracy or precision. And doubles are 64-bit in size and they can represent a larger precision up to 15 decimal places. So accordingly, according to your need, you can pick whatever you need. Now we have Boolean types. So Boolean types represent simple logical values. So any kind of logical result can be represented as booleans. They only have two values. Either a boolean can be true or it can be false. So booleans represent logical values. So a logical solution to a logical condition. Now we have tuples. So what are tuples? Tuples are a group of multiple simple data types. So tuples is a new addition and that is exclusive to Swift. And tuple is a very tuple is a very powerful concept as it gives you the ability to bunch simple type of data that are logically related, that makes sense if they are together. So let me show you an example and it will make you clearer. So let me open Xcode and show you an example. So I've created a project, not a project but a playground called data types and variables. So let me create a tuple for you. So before I show you tuples, let me show you example of integers, floating points and booleans. So before I show you tuples, I need to show you what are simple type of data. So let's first do integer. So we have, say, again, any kind of integer can be a constant or can be a variable. So let me quickly give you an example of constant. So let's say date, let's say date of birth is this. So 15 January 1990. So this is a constant. So date of birth is a constant. So when I told you a constant cannot be changed, so let's test it. Let's check if it is true. So I'll say DOB. I'll try to change the date of birth. Let's say I want to change it to, say, I want to change the year. So 1991 January 15th. Let us see what happens. So compiler is giving us error and it is saying cannot assign to a value DOB is a let constants. So as we have already defined our date of birth as a constant, we cannot change it. So this is true. Now let's see a variable. So where age is 34. So as we already discussed, variables are subject to change. So let me increase the age by 1. So age plus equal to 1. So I have incremented the age by 1 and I will simply print my age. Okay, let me quickly run it. So our program has run and we have not encountered, that means compiler is okay with us with changing these variable. So again, our age was 34 and our output is 35. So we have successfully incremented our age variable. So again, this was a variable. So let me show you different types of data types. So first was integer. So again, when we said where age is 34, this was an example of integer. So we can also write it as age int. But as you know that Swift is a very advanced language and it comes with a very advanced compiler. The compiler, by the assignment of this value, knows that this variable is of type integer. So this is equivalent to writing it as this. So we do not need to write int. Compiler is smart enough. Again, the size of this integer will depend upon the architecture of your processor. Again, I have x64 computer, so this will by default will be a 64-bit. If you need, say, 8-bit integer, you can simply say int 8. Again, if compiler is able to hold this value, if the integer is able to hold this value, it will hold, otherwise it will give an error. As we have already seen, the integer can only go up to 1 to 7. So if I say 1 to 7, so 8-bit integer will give us no error. So if I say 1 to 8, compiler is giving error. Integer literal 1 to 8 overflows. So 8-bit integer cannot hold the value 1 to 8. But if we say unsigned integer, again, we already seen it can hold the values up to 255. So 128 is lesser than 255. So the unsigned integer can be assigned a value of 128. So by default, so in the most cases, you will never need to specify what kind of int you are using. By default, if you use x64, 64-bit integer, it will suffice. So you do not need to specify separately what kind of integer you need. So same is true with floating points. If float, let us say value of pi is 3.14. okay, so again, compiler is smart enough. So by if you assign any variable and a literal float value, it will pick the type of that variable as a double. So if you do not specify the type of the float, it will by default pick up as double. So writing this where pi is equals to 3.14 implicitly means this. So pi double equal to 3.14. So compiler is smart, you do not need to tell it. Again, if there are some cases that you need specifically to use a float, you can simply say float. Okay, so if you need lesser of a precision, so you do not need high precision, so you have to explicitly tell the compiler by writing float. So I have created a float. Now again, booleans are simple yes and no. So booleans may represent a choice or a result. So say I will say result. So result can be true or false. So I'll just say true. Now we have created a boolean whose value is true. So again, this boolean will only hold true or false value. If I try to change it to say false, I will encounter no error because true or false are valid values for a boolean. Say again, if I try to change it to any other thing, say 1 to 8, compiler will give me an error, says cannot assign a value of type int to a type bool. So bool can only have true or false as its value. Now we have covered simple data types. Now let's move on to a tuple. So what is a tuple? As I have already explained, tuple is a group of simple data types that are logically related. So what are the simple properties that you can think of that are logically related? So again, continuing the example of a person can have a name. So a name is rarely changed. So I'll consider it a constant. So let's say let name. I'll assign it my name, Brijender. Now let age. Okay, again age is a variable. Age is subject to change. I will say 34. Now let's take one more. Let's say gender. Again, gender is usually not subject to change, so I will say male. Again, I have to define what kind of property it is. Is it a constant or a variable? So it is a constant for me. So these are the simple type of data, simple type of properties that make sense if they are bundled together. So let us create a tuple out of it. So how you would create a tuple? So let's give it a name of person. Let person be name, age, and gender. Now this is what a tuple means. Now we have created not a person, a person. So we have created a tuple. The tuple's name is person, and the person has three properties: name, age, and gender. And we have already assigned our values to each of these properties. So name is Brigender, age is 34, gender is male. So let us check if we have correctly created our tuple. So let us try to print each of these values. So let's say print person dot. So again, we have different ways of accessing the values of a tuple. So we can use the indices. So 0 will be the name, 1 will be the age, 2 will be the gender. So let us do this way first. Print person, print person. Let us see what is the output. So person dot 0 is name, that is Brigender. Person dot 1 is age, that is 34. Person dot 2 is gender, that is male. So we have successfully created a tuple. So we have created a tuple out of these simple values, and we have shown that our tuple has been successfully created. So there is one another way that you can access these properties. So as you have already seen, I have created this tuple out of these properties. So we have composed a tuple. In similar way, we can decompose or deconstruct a tuple. So let me show you example of deconstruction. So let me create this tuple again. This time I will type the values here itself. Say Brigender, say age is 34, say gender is male. Okay, so I have created a tuple with these properties. Now I can deconstruct them. So I can say let, I have deconstructed here. This line deconstructs or decomposes this tuple into three different properties. And in similar way, I can show you what will happen if I say print the name, print the age, and print the gender. Okay, so let's run our program. Our program has run. Okay, let me clear the console for you. So I've cleared the console. I'll run the program again. Yeah, so our name is Brigender, age is 34, and gender is male. So this is another way to access the properties of a tuple. The second way is by decomposing or deconstructing the tuple. So again, what was a tuple? A tuple was a group of simple data types, as I've already shown you. And it is useful for return values of function. So you when we will learn functions, you will learn that a function can only return a single uh, value, maybe it a complex or a simple value. But again, if you want to return more than one uh, value from a function, and if those values are fairly simple and fairly logically related, then we can simply return a tuple that contains more than one value. So we can return say 3 4 properties, 4 5 properties that are simple data types and that makes sense. If they are bundled together, we can simply return a tuple. So that is why tuples are useful. Now we have data type conversion. So when you will be writing code, so there will be a point in time where you will need to convert one data type into another. So how will you handle such cases? So we have integer to integer conversion. As we have already seen, we have different type of integers. We have 8-bit, 16-bit, 32-bit and 64-bit integers, and we might need to convert between each of these integers. And now we have integer to floating point and vice versa. So similarly, we might need to convert an integer into a float or a double, and from float or double to an integer. So how will you handle such cases? So let us see integer to integer conversion. So as per Swift, the conversion must be explicit. So what do we mean by this? So if you are familiar with any other programming language, you might have learned that some programming environments allow you to implicitly convert from one data type to other. But again, this kind of implicit conversion were a source of errors or bugs in your code. So Swift prohibits such implicit conversions. So by assigning a variable to another type of variable will not suffice you to convert between those data types. So you will need to explicitly tell the compiler by writing your code that you want to convert between these values. So I'll show you the example. And conversion must happen by initializer. So what do we mean by this? So let me show you an example. Again, let me go to Xcode. And let us convert. So let us convert. So we have integer. Say we have let small. We have an integer called small, so I will say it is of type. Let us take a small integer, let it be int 8. I will give it an value of 1 to 7, the maximum value it can hold. I'll also create a large integer, so I will say 16. So I'll say int 16. So say 3 to 7, 6, and the largest value it can hold. Okay, not the largest, let's say only 30,000. And again, let us say 100. So again, I have created two integers. One is of type int 8, another is of type int 16. So let us see what will happen if I try to print the sum of these two integers. So for the sum to happen, one kind of integer must be converted into another kind. So let's do it. Let us try to do it implicitly. So I'll say small plus large. So will it happen? No. So the compiler says binary operator plus cannot be applied to operands of type int 8 and int 16. So the compiler is saying this plus operator is not equipped to handle different types of integers. So these two integers must be of same type. So one way we can do is, so as again we can see that we cannot convert this integer 16 into integer 8 as, because 30,000 will never be able to fit inside an int 8 type integer. So the only way is to convert from small to big, because int 16 can hold a value of 100. So I will convert it. So the second point, we learned that conversion must happen by way of initializers. So initializers, we will learn later what are initializer. For the time being, initializers are a way to create an object. In this case, initializer will create an integer of a specific type. So I'll try to create an int 16 from a small integer. So this int 16, so this int 16 and this declaration here is an initializer. Okay, so we are passing it a value of small of type int 8. So this will create us an integer that is of type int 16 with the value of 100. So we have converted int 8 into int 16. Let us try to print the output. So 30,100. So again we were able to complete our operations because we were able to convert between different type of integers. So this is how you will do it. Now let us see next type of conversion, which is integer to floating point and vice versa. So again, in this case, the conversion must be explicit. You cannot convert from float to integer and integer to float implicitly. You will need to use initializer. And again, in case of conversion from floating point to integer, the decimal part, the fractional part will be truncated. So when we will be converting from, say, a floating point, say a value of pi to an integer, the fractional part will be truncated and we will get an integer that will have a value of 3. Let me show an example. Again, let me open Xcode. So say let's say let us have an int. Let us have int, say integer, say 3. So let us say number, let us say fraction, let us say whole number. Let us say fraction. So fraction. So what I'm trying to do is I'm trying to construct the value of pi from an integer and a double, kind of a float type. So let us try to do it implicitly. So I will say print the value of the integer, say whole number and fraction. So again, The compiler gives us error, says binary operator plus cannot be applied to operands of type int and double. So we cannot operate between int and double, we need to convert. Either we can convert from a float to integer or an integer to float. So let me show you the first example. Let me convert this whole number into an integer. Again, I will need a initializer. So I'll say double, I'll pass it whole number, and again I will try to print the value. So 3.14, we have the value of pi. Let me show you other way around. We can convert from double to an integer, but again, as I have already told you, if we convert from double to an integer, a floating point to an integer, the decimal part, the fractional part will be dropped. So I will just simply say int, pass it fraction. Let us see what the output will be. So it is 3. So again, whole number is 3. I have converted this fraction into a integer, so the decimal part has been dropped. So 0.14 part has been dropped. Then 3 plus 0 is 3. We have a integer. So this is how you will do the conversions. Comments. Now, while writing your code, so say you're writing code, you're writing an application, and this application, this piece of code becomes very huge. Now, after a certain point of time, so say if you wrote a code, so that is 100 or 200, 300 lines of code, and say for after a day you come back to the same code. Now you will have very difficult time trying to understand what you yourself wrote, and that is where comments come in handy. So comments helps you to document your code. So let us see what are comments and how they help you document your code. So let us first see a single line comment. So we have single line comments and multi-line comments. Okay, let me show you an example of both. So this is a single line comment. So anything after these double slashes will be ignored by compiler. So compiler knows whatever I'll write in this line is not a piece of code. It is supposed to be a documentation. It is supposed to be the metadata of the upcoming code or line that you will be writing. So say this is a single line comment and will be ignored by the compiler. Okay, so I can again keep coding. Again, I'll create a single line. I am creating a variable named age. So I can say let age is 25. Okay, so as you can already see, I have written two single line comments, and whatever I have written inside is being ignored by the compiler, and it is serving me the purpose of giving extra information about the code. Again, I can say let name be Tejender. Again, I can also write a multi-line comment. So say if you want to write a code if you want to write a comment that spans multiple line, you can just go slash and asterisk star asterisk, and between these you can go, this is a multi-line comment I am creating a name variable. I am creating a name constant. So again, we have written a multi-line comment. So as you can see, comments are helpful if you are documenting your code, if you are doing documentation about your code. So this will help if you are working with multiple people on a project and the other person wants to know what a particular piece of code is doing. So comments are very helpful. So this was all for the third video of this tutorial, and I'll see you in the next video.